terrestrial planet. These are the worlds built from rock and metal, with hard surfaces you could in principle stand on. They form in the warm inner region of a young star system, close enough that only heavy materials like silicate rock and iron could survive the heat and clump together. Mercury, Venus, Earth, and Mars are the four in our own system. They tend to be small and dense, with thin atmospheres or none at all. So far, this is the only kind of planet ever found to carry life. Gas giant. A gas giant has no solid surface to speak of. It is a vast ball of hydrogen and helium wrapped around a small, dense core. Worlds like this form far from their star, out beyond the frost line, where it is cold enough for ice and gas to gather in enormous quantities. Jupiter and Saturn are our local examples, and Jupiter alone holds more than twice the mass of every other planet in the solar system combined. Their gravity is strong enough to hold onto dozens of moons and shape the orbits of everything around them. Ice giant. For a long time, these were grouped with the gas giants, until astronomers recognized in the 1990s that they are a separate class. An ice giant is made mostly of heavier substances, such as water, ammonia, and methane, which planetary scientists loosely call ices, surrounding a rocky core with only a thin outer layer of hydrogen and helium. Uranus and Neptune are the two we know best. The methane in their atmospheres absorbs red light and gives both worlds their deep blue color. They sit in the cold outer reaches, far from the warmth of the sun. Dwarf planet. A dwarf planet is large enough that its own gravity has pulled it into a round shape, but not powerful enough to sweep its orbit clean of other debris. That distinction is why Pluto was reclassified in 2006, a decision that is still debated today. Ceres sits in the asteroid belt, while Pluto, Eris, Haumea, and Makemake drift far out in the Kuiper belt. They are small, cold, and often accompanied by moons of their own. There are likely many more of them still waiting to be found at the edges of the system. Super-Earth. A super-Earth is a rocky world heavier than our own, somewhere between the mass of Earth and that of Neptune. None exist in our solar system, yet they appear to be one of the most common kinds of planet in the galaxy. Their stronger gravity would hold a thicker atmosphere and flatten their mountains. Some orbit within the narrow region where liquid water could exist, which makes them a leading target in the search for life beyond Earth. Whether any of them are truly habitable is still an open question. Mini Neptune. Slightly larger than a super-Earth, a mini Neptune wraps a rocky or icy core in a thick blanket of hydrogen, helium, and water vapor. Like the super-Earth, it has no counterpart in our own system, and it too is very common across the galaxy. The two types are separated by a narrow gap in size that astronomers call the radius valley, a boundary that seems to mark where a planet keeps its atmosphere, or has it stripped away by its star. Beneath that heavy air, the surface would lie under crushing pressure. Ocean world. An ocean world is a planet covered entirely in water, with no continents breaking the surface. On some, the ocean lies open to the sky. On others, it is sealed beneath a thick shell of ice. Water may make up a large fraction of the whole planet, far more than the thin film that coats the Earth. These worlds can form far from their star and then migrate inward, carrying their ice with them until it melts. They are a strong candidate in the search for life, though a planet-wide ocean that deep would be a very different environment from anything on Earth. Lava planet. A lava planet orbits so close to its star that its day side is hot enough to melt rock. The surface there is not solid ground, but a glowing ocean of magma. Many of these worlds are tidally locked, keeping one face turned toward the star, while the other stays in permanent night. Their atmospheres can be made of vaporized rock, and in some models, minerals condense high above and fall back down as a rain of stone. They are among the most hostile places we know of. Carbon planet. Most rocky planets, including Earth, are built mainly from oxygen and silicon. A carbon planet forms instead in a region rich in carbon, and that single difference changes what its interior is made of. Under enough heat and pressure, its deep layers could hold graphite and even thick sheets of diamond. Such a world would look and behave nothing like our own, with dark surfaces and a chemistry unlike anything on Earth. No confirmed example has been found yet, but the ingredients to build one are known to exist around other stars. Iron planet. An iron planet is a dense world made almost entirely of metal, with a massive iron core and little or no rocky mantle around it. Mercury leans in this direction, its metal core taking up far more of the planet than is normal. One idea is that these worlds began as ordinary rocky planets and then lost their outer layers in a violent collision, leaving the heavy center behind. What remains is small, dense, and heavy for its size, essentially the metal core of a planet that was once larger, hot Jupiter. A hot Jupiter is a gas giant that orbits its star not from a safe distance, but from scorchingly close, completing a full year in only a few days. The first planet ever found around a sun-like star, back in 1995, was one of these, and it forced scientists to rethink how planets form. A giant like this could not have been born so close to its star. It must have taken shape farther out and then spiraled inward over time. Its atmosphere is superheated, and the side facing the star can be hot enough to glow. Hot Neptune. Smaller than a hot Jupiter, but shaped by the same fate. A hot Neptune is a Neptune-sized world locked in a tight, blistering orbit. The intense radiation pouring off the nearby star can boil away its atmosphere, stripping gas into a long, comet-like tail. Very close to their stars, there is a region where almost none of these planets survive, a barren zone astronomers call the Neptune Desert. The few that hold on there are studied closely, because they show how a planet's air can be torn away by the star it orbits. Puffy planet. A puffy planet has the size of a giant, but almost none of the weight, giving it a density lower than water, and in some cases closer to cotton candy. The heat from its star inflates its outer layers, swelling the whole world far beyond what its mass should allow. These planets are fragile and remarkably light for their size. Studying them helps astronomers understand how a planet's atmosphere responds when it is filled with energy and stretched thin across an enormous feather-light sphere. Pulsar planet. This kind of world orbits not a living star, but the dead remnant of one. When a massive star explodes and collapses, it can leave behind a rapidly spinning core that sweeps beams of radiation across space. The very first planets ever discovered beyond our solar system, found in 1992, circle exactly such an object. These worlds are thought to have formed from the debris of the explosion that destroyed the star, and they sit bathed in radiation, the remnants of that catastrophe. Rogue planet. A rogue planet belongs to no star at all. Cast out of the system where it formed or born alone in the dark, it drifts through the galaxy with no sunrise to mark its days. There may be billions of these wanderers in the Milky Way, perhaps even more of them than there are stars. Without a star to warm it, its surface would be frozen solid, and yet the heat trapped deep inside might still keep a hidden ocean liquid beneath the ice.